the object that should not exist. In 1938, a German archaeologist named Wilhelm Koenig was working in the collection of the National Museum of Iraq in Baghdad. Koenig was examining objects that had been excavated from Qujut Rabu, an archaeological site near the village of Al-Mahmudiyya, south of Baghdad, in the region that had once been the heart of the Parthian Empire, the great Iranian civilization that ruled Mesopotamia and Persia from roughly 247 BCE to 224 CE. The objects were mostly unremarkable by archaeological standards: pottery, tools, everyday items from a culture that had ceased to exist nearly 2,000 years earlier. And then Koenig picked up a small clay jar. The jar was approximately 14 centimeters tall, about the size of a large coffee mug. It was made of reddish-brown clay, sealed at the top with bitumen, the black tar-like substance that the ancient inhabitants of Mesopotamia used as a waterproof sealant for everything from boats to buildings. Inside the bitumen seal was a copper cylinder, rolled from a flat sheet and soldered along the seam. Inside the copper cylinder was an iron rod, suspended from the top, not quite touching the bottom of the cylinder. The iron rod was also held in place by bitumen. Koenig examined the object carefully. He had seen a great deal of ancient technology in his career, and what he was looking at made him deeply uncomfortable, not because it was frightening, but because he recognized what it was. He had seen this configuration before, in a modern electrical laboratory. He was looking at a galvanic cell, the essential component of an electrochemical battery. A metal rod inside a different metal cylinder, separated by a gap, designed to hold an electrolytic solution between them. When filled with an acidic liquid, this assembly would produce a small electrical current. It was, in structure and in principle, identical to the battery that Alessandro Volta had invented, and was celebrated for inventing, in the year 1800. Except that this jar was approximately 2,000 years old. To understand the Baghdad Battery in context, you need to understand the world it came from. The Parthian Empire was one of the great powers of the ancient world, controlling the territories that are now Iran, Iraq, and parts of Central Asia for nearly 5 centuries. At its height, it stretched from the Euphrates River in the west to eastern Iran in the east, encompassing some of the most fertile land and the most strategic trade routes in the ancient world. The Parthians were, by any measure, a sophisticated civilization. They were literate, with a tradition of writing in several scripts and languages. They were skilled metallurgists, producing fine metalwork in bronze, silver, and gold. They were accomplished engineers, building cities, irrigation systems, and palaces. They traded extensively with Rome to their west and with China to their east, and the Silk Road that connected these distant civilizations passed through Parthian territory. The site at Qujut Rabu where the jar was found was a Parthian settlement, a village or small town of the kind that studied the Mesopotamian landscape in the early centuries of the Common Era. The jar was found along with other objects that dated to the Parthian period, roughly 250 BCE to 224 CE, suggesting that it was used during the same period. The Parthians were not primitive. They were the inheritors of thousands of years of Mesopotamian civilization, of the Babylonians and Assyrians and Sumerians who had built some of the most sophisticated urban cultures the ancient world had seen. The idea that they might have discovered a natural phenomenon that later generations would formalize as electrochemistry is not, on its face, impossible. Wilhelm Koenig published his identification of the Baghdad object as a battery in 1940 in a monograph on ancient electrical knowledge. His identification was, in the context of 1940 archaeology, startling. The conventional narrative of technological history placed the invention of the battery firmly in the late 18th and early 19th centuries, Volta's pile of 1800, preceded by Luigi Galvani's observation of electrical effects in frog legs in the 1780s. The idea that a version of this technology had existed 2,000 years earlier was not merely surprising, it implied that something had gone wrong with the history of science, that knowledge had been discovered and then lost in a way that the standard narrative did not account for. Koenig's identification was not immediately accepted by the archaeological community. Some of his colleagues found the identification plausible but the implications too large to accept without more evidence. Others were skeptical that the object was a battery at all, suggesting alternative explanations ranging from storage vessels for scrolls to containers for sacred liquids. Koenig's monograph attracted limited attention in the years following its publication, partly because it appeared during the Second World War and partly because the broader archaeological community had not yet developed the frameworks for thinking about what would later be called out-of-place artifacts, objects that appear to demonstrate knowledge or technology inconsistent with their historical period. The Baghdad Battery might have remained a minor footnote in the history of Iraqi archaeology if not for a growing popular interest in ancient mysteries in the post-war period, and for a series of experiments that would eventually demonstrate, beyond serious dispute, that the object could indeed function as a battery. The most important step in the Baghdad Battery's journey from curiosity to controversy was the series of experiments conducted to determine whether the object actually worked. The first significant experiment was conducted in 1940 by Willard Gray, a scientist at the General Electric High Voltage Laboratory in Pittsfield, Massachusetts. Gray constructed a replica of the Baghdad jar using the same materials and dimensions as the original, filled it with grape juice as an electrolyte, and measured the electrical output. The replica produced approximately half a volt of electricity, a small but real and reproducible electrical current. Subsequent experiments, conducted by various researchers over the following decades, confirmed and refined Gray's results. Depending on the electrolyte used, grape juice, vinegar, lemon juice, copper sulfate solution, replicas of the Baghdad Battery produced between half a volt and just over 2 volts of electricity. The original jar, if connected in series with multiple similar jars, could have produced a significant current. These experiments established beyond serious doubt that the Baghdad Battery could function as a battery, that it was not a coincidental arrangement of materials but a configuration that produces real electrical output when filled with an appropriate liquid. What the experiments could not establish was whether the ancient people who made the jar knew it could produce electricity, or whether they were using it for that purpose. A design that works as a battery might have been made with an entirely different purpose in mind, or might have been the product of craft traditions that happened to produce this configuration without any understanding of its electrical properties. The Baghdad Battery is not unique. The most important fact that popular accounts of the Baghdad Battery often omit is that Koenig found not one but several similar jars, approximately a dozen, in the same region, dating to the same period. And in subsequent years, archaeologists working in the broader area have found additional examples that appear to share the essential design characteristics. The existence of multiple similar objects is significant in 2 ways. It suggests that this was not an accidental arrangement, not a jar that happened to contain a copper cylinder for unrelated reasons, whose electrical properties were never noticed. The consistency of the design across multiple examples suggests deliberate construction according to a specific pattern. It also suggests that whoever made these objects was producing them in some quantity, possibly as a standard item for a specific purpose. Something was being done with these jars, regularly enough that they were made in multiples, by craftspeople who had learned to produce them consistently. What that something was remains the central unanswered question. The Baghdad Battery's most fundamental problem, the reason it remains genuinely mysterious rather than definitively explained, is the absence of context. No ancient text from the Parthian period, or from any of the ancient civilizations that preceded it in Mesopotamia, contains any description of electrical phenomena. No ancient drawing depicts anything resembling a battery or its use. No ancient tool or device has been found that would require electricity to function. No metalwork from the period shows the specific characteristics, the thin, even metallic coatings, that would most naturally be produced by electroplating. In archaeological terms, the Baghdad Battery is an orphan. It exists without the documentary or material context that would allow researchers to determine its purpose with confidence. It was found in a context that was not specifically excavated or documented in the systematic way that modern archaeology requires. Its exact find spot and associated materials were not recorded with the precision that would allow definitive analysis. This absence of context is the source of both the mystery and the frustration. The object demonstrably works as a battery. And yet there is no evidence from the ancient world that suggests anyone knew it worked as a battery, or used it as one. The Baghdad Battery does not stand entirely alone among claims of ancient electrical knowledge. The ancient Egyptians produced metalwork, gold-plated objects, silver-plated ceremonial items, of extraordinary quality, and scholars have debated for decades whether some of this plating could have been produced by electroplating rather than by mechanical techniques. Some Egyptian artifacts show extremely thin, even coatings of precious metal over base metal that are difficult to explain by the mechanical methods available, and some researchers have argued that electroplating with simple battery technology would explain them. Ancient Greek texts, particularly those associated with Thales of Miletus in the 6th century BCE, describe the observation that rubbing amber with fur causes it to attract small objects, the phenomenon we now understand as static electricity. This observation shows that the ancient world was not entirely ignorant of electrical phenomena, even if the knowledge was not systematized. Various ancient texts from India and Egypt contain descriptions of phenomena that some researchers have interpreted as possible references to electrical effects, though these interpretations are contested and the relevant passages are ambiguous. None of these parallels constitutes proof that the Baghdad Battery was understood and used as a source of electrical current. But they establish that the ancient world was not hermetically sealed against the observation of electrical phenomena, and that the idea of ancient electrical knowledge is not categorically impossible. The jar sits in the museum. It is a small thing, smaller than you might imagine, given its significance. Reddish-brown clay. A seam of black bitumen at the top. And inside, invisible from the outside, the copper cylinder and the iron rod that have been waiting for 2,000 years to produce their quiet half-volt of current. In Part 2, we examine what the experiments actually showed and what they did not show, the precise nature of the evidence for the battery interpretation. Rest here. The jar is very old. It is very small. And it may change everything we think we know. Does it actually work? Let me be precise about what the experiments demonstrated. The experiments demonstrated that a replica of the Baghdad Battery, when filled with an acidic liquid, produces a small electrical current. This is a real, reproducible, measurable result. It has been replicated by multiple independent researchers using different materials and different electrolytes, and the results are consistent. What the experiments did not demonstrate is equally important. They did not demonstrate that the original jar was ever filled with an electrolyte. They did not demonstrate that the ancient makers of the jar knew it produced electrical current. They did not demonstrate that the jar was used for any purpose related to electricity. The battery interpretation rests on the observation that the jar's design is consistent with a battery, and that a replica works. It does not rest on any positive evidence that the jar was used as a battery. This distinction, between a design that works and a design that was used for that purpose, is the central issue in the Baghdad Battery debate. And understanding it clearly is essential for evaluating the competing theories about what the jar was for. The Baghdad Battery works because of a principle called galvanic action, the same principle that Volta formalized in 1800 and that underlies every modern battery. When two different metals are immersed in an electrolytic solution, a liquid that can conduct electricity, typically because it contains dissolved acids or salts, a chemical reaction occurs at the surface of each metal. At one metal, the anode, oxidation occurs, the metal loses electrons to the solution. At the other metal, the cathode, reduction occurs, ions in the solution gain electrons from the metal. The flow of electrons from the anode to the cathode, through an external circuit, is what we call electrical current. In the Baghdad Battery, the iron rod is the anode, it oxidizes when immersed in acidic solution, losing electrons. The copper cylinder is the cathode, it gains electrons from the ions in the solution. The acidic solution, vinegar, grape juice, lemon juice, or any of several other liquids that were available in ancient Mesopotamia, provides the ions that carry the charge between the metals. The voltage produced depends on the specific metals and electrolyte used, but for the iron-copper combination with common ancient electrolytes, the range is approximately 0.5 to 2 volts. This is a modest voltage, comparable to a modern AA battery, which produces 1.5 volts. The current produced is also modest, small fractions of an ampere in most experiments. But multiple jars connected in series would produce proportionally higher voltages, and the current, while small, would be sufficient for certain applications. The most thorough and widely cited replication experiments were conducted in the 1970s and 1980s by researchers who were specifically interested in testing the electroplating hypothesis. On Egebrecht, a German archaeologist and director of the Roma and Pelagius Museum in Hildesheim, conducted experiments in the 1970s that went beyond simply demonstrating that the battery produced current. Egebrecht and his colleagues connected multiple Baghdad battery replicas in series, increasing the total voltage, and used the resulting current to electroplate a small silver statuette with a thin layer of gold. The electroplating worked. It produced a thin, even coating of gold on the silver surface, a result consistent with the kind of plating that has been found on some ancient metalwork. Egebrecht's experiment was significant because it demonstrated not just that the battery could produce current but that the current it produced was sufficient for a specific practical application, electroplating, that would have been valuable to ancient metalworkers. If ancient craftspeople had discovered that filling these jars with acidic liquid and connecting them to metal objects produced thin metallic coatings, they would have had a practical reason to use and refine the technology. Subsequent experiments by other researchers confirmed that ancient metallic coatings on some Iraqi artifacts were thinner and more even than would be expected from mechanical gilding techniques, and were consistent with electroplating. This is not proof that the Baghdad battery was used for electroplating, but it is consistent with it. The archaeological analysis of the Baghdad battery, the attempt to understand it through its material composition, its manufacturing techniques, and its context, has produced a more nuanced picture than the popular account typically presents. Detailed analysis of the copper cylinder has shown that it was manufactured with considerable skill, the copper sheet was of consistent thickness, the seam was soldered cleanly, and the overall construction was precise. This is not a crude object made by someone experimenting with unfamiliar materials. It is a well-made object produced by someone who knew what they were doing. The bitumen sealing at the top of the jar is also significant. Bitumen was used in the ancient Near East as a waterproof sealant and adhesive, and its use here to seal the copper cylinder within the clay jar suggests that the contents of the cylinder were meant to be contained, that the jar was designed to hold something inside the cylinder, not just to store the cylinder itself. The iron rod shows oxidation consistent with having been immersed in an acidic liquid, but this could be the result of natural groundwater exposure over 2,000 years of burial, not evidence of deliberate use as an electrode. The overall conclusion of the archaeological analysis is that the object was deliberately constructed with considerable skill, that its design is consistent with battery function, and that there is no direct physical evidence of how it was used. The battery interpretation is not the only serious explanation for the Baghdad Battery, and the alternatives deserve fair examination. The most commonly proposed alternative is that the jars were used to store papyrus scrolls or parchment documents. Ancient Near Eastern cultures did store documents in clay jars for protection, and the dimensions of the Baghdad Battery are consistent with holding a rolled scroll. On this view, the copper cylinder was not a battery component but a protective sheath for a document, and the iron rod held the document in place. This explanation has the advantage of explaining the design without invoking electricity. The problem is that no scroll or document remnants were found inside the jars, and the bitumen sealing that would protect a scroll from moisture would also function to seal an electrolytic solution inside. It is equally consistent with both uses. A second alternative proposes that the jars were used for religious or magical purposes, that the small electrical shock produced when a person touched the electrodes while the jar was filled with electrolyte was used in religious rituals to produce apparently miraculous effects. Ancient priests who understood that touching the jar produced an unexpected physical sensation could have used this knowledge to create or enhance religious experiences. A third alternative proposes that the jars were used for pain relief, that the small electrical current was used therapeutically, perhaps to treat localized pain. Ancient Egyptian medical texts do describe the use of electric eels for pain treatment, and small electrical currents do have analgesic effects that have been exploited in modern medical devices. None of these alternatives is definitively ruled out by the available evidence. The Baghdad Battery occupies an unusual position in scholarly discourse. It is taken seriously by some reputable scientists and archaeologists while being dismissed as pseudoscience by others, and the divide does not always fall along obvious lines. The mainstream archaeological position tends to be skeptical, not because the battery interpretation is physically impossible, but because of the absence of supporting evidence. The argument runs, if the Parthians were using electrochemical cells, we would expect to find evidence of this in their texts, their art, their tools, or their metalwork. We find none. The most parsimonious explanation for the jars is therefore not that they were batteries but that they were used for some more prosaic purpose that we have not yet identified. The pro-battery position responds that absence of evidence is not evidence of absence, that we have only a small fraction of the texts and artifacts from the Parthian period, that electroplating might not have been practiced widely enough to leave extensive material evidence, and that the specific design of the jars is difficult to explain as anything other than a deliberate battery configuration. Both positions are reasonable given the evidence. The honest assessment is that we do not know what the jars were for, and that the battery interpretation is plausible but not proven. The Baghdad Battery has become one of the most widely discussed examples of what is sometimes called out-of-place artifacts, objects that appear to demonstrate knowledge or technology inconsistent with the standard historical narrative. It was featured in the television series Mythbusters, whose hosts built replicas, confirmed that they produced electricity, and used them to electroplate a small object. The episode concluded that the battery hypothesis was plausible, though the hosts were careful not to claim that the ancient Parthians definitely understood or used the electrical properties of the jars. It has appeared in countless books, documentaries, and online discussions about ancient mysteries, typically alongside other claimed anomalies, the Antikythera mechanism, the Nazca lines, the pyramids. In popular culture, it has become a touchstone for the argument that ancient peoples were more sophisticated than mainstream history acknowledges, that we have lost knowledge, that civilization's trajectory is not as linear as we assume. This popular framing often goes further than the evidence warrants. The Baghdad Battery is genuinely mysterious and genuinely interesting. It does not require alien intervention, a lost advanced civilization, or the overthrow of established history to be taken seriously. It requires only the acknowledgement that ancient people sometimes discovered things that were later rediscovered, that knowledge can be lost, and that the absence of evidence for ancient electrical knowledge is not proof of its absence. The replicas work. Half a volt from grape juice. More from vinegar. Enough, connected in series, to plate a gold layer on a silver statue. And the original jar, sitting in a Baghdad museum, says nothing about whether it was ever filled with grape juice, or vinegar, or anything at all. In Part 3, we examine the competing theories about what it was for, the electroplating hypothesis, the religious hypothesis, the medical hypothesis, and what each one requires us to believe. Rest here. The copper is green with age. The iron has oxidized to rust. And the question remains unanswered. What was it for? There are serious theories about what the Baghdad Battery was used for. I want to go through each one carefully, not to dismiss any of them, not to advocate for any of them, but to understand what each one actually requires and what evidence supports it. The theories are electroplating of metals, religious or ritual use, therapeutic or medical use, and a purpose we have not yet identified. Each of these has advocates among serious researchers. None of them is proven. And the honest position, at the end of the analysis, is that we genuinely do not know. But the not knowing is itself interesting. The Baghdad Battery is not a mystery that resists explanation because the object is poorly documented or poorly understood. It is a mystery that resists explanation because we have an object that demonstrably works as a battery, and no evidence for how it was actually used. That gap, between capability and evidence, is where the real mystery lives. The most technically developed hypothesis about the Baghdad Battery's purpose is the electroplating hypothesis, the idea that the jars were used to deposit thin coatings of one metal on objects made of another. Electroplating works by using electrical current to drive the deposition of metal ions from a solution onto a conductive surface. If you dissolve a gold salt in a liquid, connect a gold object to the positive terminal of a battery and a silver object to the negative terminal, and immerse both in the solution, gold ions will migrate from the solution and deposit on the silver surface, creating a thin gold coating. This process, formalized and industrialized in the 19th century, produces coatings that are thinner, more even, and more controllable than the mechanical gilding techniques available in the ancient world, hammering gold leaf onto a surface, or applying an amalgam of gold and mercury that is then heated to drive off the mercury. The key evidence for the electroplating hypothesis is twofold. First, the Baghdad Battery replicas produce sufficient current for electroplating. Egebrecht demonstrated this directly. Second, some ancient metalwork from the Middle East shows coatings that are thinner and more even than mechanical techniques would readily produce. The weakness of the hypothesis is the absence of any ancient text or image describing or depicting electroplating, and the absence of the associated infrastructure that commercial electroplating would require: large quantities of metal salts, systematic setups for the process, evidence of production at scale. The religious hypothesis proposes that the Baghdad Battery was used in temple or ritual contexts to produce effects that would seem miraculous to worshippers unfamiliar with electrical phenomena. Ancient temples were centers of carefully managed spectacle, places where priests maintained elaborate systems for creating impressive visual, acoustic, and tactile effects that enhanced the apparent power of the divine. Ancient Greek and Egyptian temples are known to have incorporated mechanical devices, steam-powered automata, hydraulic systems, clever acoustics, to create effects that would overawe visitors. A small electrical shock, the kind that would be produced if a worshipper touched the terminals of a Baghdad battery filled with acidic liquid, would be a startling and inexplicable experience to someone who had never encountered it. The tingling, the involuntary muscle contraction, the mild pain, these would be consistent with what might be interpreted as a divine touch, a sign of divine presence, a test of worthiness. The religious hypothesis has the advantage of explaining why ancient people might have preserved and replicated the battery design without understanding its electrical properties. They would have understood it in terms of religious power, not electrical power. A jar that makes people feel something when they touch it would be religiously valuable even to people who had no concept of voltage or current. The weakness is, again, the absence of any textual or material evidence connecting the jars to temple use. The therapeutic hypothesis proposes that the Baghdad battery was used for a form of ancient electrotherapy, the application of small electrical currents to treat pain or illness. The use of electricity for medical purposes predates the formal understanding of electricity by centuries. Ancient Egyptian medical texts, dating to approximately 2750 BCE, describe the use of electric catfish, Malapterurus electricus, a species native to the Nile, to treat pain. Greek and Roman physicians described the use of torpedo fish, electric rays, to treat headaches and gout, the ray being placed on the affected area until the pain subsided. If ancient physicians were already using naturally occurring electrical sources for pain relief, the discovery of an artificial source that produced similar effects would have had obvious medical value. A Baghdad battery filled with acidic liquid and connected to metal rods that could be applied to the skin would produce exactly the kind of transcutaneous electrical stimulation that modern physiotherapy uses for pain relief. The evidence for this hypothesis is circumstantial but coherent. Ancient electrical therapy using natural sources is documented. The Baghdad battery can produce the same kind of stimulation, and pain relief is a compelling practical purpose. The weakness is the same as the other hypotheses. No ancient text or image connects the jars to medical use. The most conservative explanation for the Baghdad battery, the one that requires the smallest departure from conventional archaeological interpretation, is that the jars were storage vessels for documents, sacred objects, or other materials, and that the copper cylinder and iron rod are coincidental features of this storage function rather than intentional battery components. The dimensions of the jars are consistent with holding a rolled papyrus or parchment scroll. The copper cylinder could have been used to protect a scroll from moisture or insects. The bitumen sealing is consistent with a storage container that needed to be airtight. The problem with this hypothesis is that it requires explaining the iron rod, a feature that makes no obvious sense as part of a scroll storage vessel. Iron rods were not typically included in ancient storage jars, and the specific placement of the rod within the copper cylinder, not quite touching the bottom, is suggestive of deliberate electrical design rather than incidental inclusion. More fundamentally, if the jars were simply storage vessels, you would expect to find remnants of what they stored, scroll fragments, organic material, something. None has been found. There is a fifth possibility that is rarely discussed but that is worth considering, that the Baghdad battery was discovered accidentally, understood empirically without theoretical explanation, and used for a purpose that its makers described in terms that do not translate easily into modern categories. Ancient technology often worked on principles that its practitioners understood empirically. They knew what happened, they knew what to do to make it happen, they did not necessarily know why it happened in terms of underlying mechanisms. Ancient metallurgists produced alloys whose properties they understood through practice without knowing anything about atomic structure or crystallography. Ancient physicians used willow bark for pain relief without knowing about salicylic acid. A craftsperson who discovered that filling a specific jar with grape juice and connecting it to metal objects produced a thin metallic coating might have described this as a property of the jar, perhaps a magical or divine property, rather than as an electrical phenomenon. The knowledge of how to make the jars and how to use them might have been transmitted as craft knowledge, without any theoretical understanding of why it worked. On this view, the absence of ancient texts describing electrochemistry is not surprising, because the ancient practitioners did not think of what they were doing as electrochemistry. They thought of it as a craft technique, a recipe, a procedure whose results were reliable even if its causes were mysterious. The original Baghdad Battery, or the original Baghdad jars, since there were several, had a complicated history in the 20th century. The objects were housed in the National Museum of Iraq in Baghdad, one of the world's great repositories of ancient Near Eastern artifacts. The museum's collection spans thousands of years of Mesopotamian civilization, Sumerian, Babylonian, Assyrian, Parthian, Islamic, and is of incalculable historical and cultural value. During the American invasion of Iraq in 2003, the National Museum of Iraq was looted. Thousands of artifacts were stolen or damaged in the chaos that followed the fall of Baghdad. The Baghdad Battery jars were among the objects whose fate was initially uncertain in the aftermath of the looting. The objects were eventually recovered and returned to the museum. But the looting of 2003 disrupted archaeological research in Iraq in ways whose effects are still being felt. Many objects were dispersed into private collections, provenance records were lost, and the institutional infrastructure for studying the collection was severely damaged. The Baghdad Battery today sits in a museum that is slowly rebuilding from catastrophe, in a country whose archaeological heritage has been damaged by decades of war and neglect. Whatever secrets the jars hold, if they hold secrets at all, they are holding them in difficult circumstances. For serious theories. No definitive evidence for any of them. Electroplating. Religion. Medicine. Storage. Each one possible. None proven. In Part 4, we ask what it would mean if the battery interpretation is correct, what it implies about the history of knowledge, the history of technology, and what we think we know about the past. Rest here. The jar is small and old and silent. It has been holding its secret for 2,000 years. What it changes if true? Let me ask the question directly. If the Baghdad Battery was a battery, if the ancient Parthians, or their predecessors, or their contemporaries in the ancient Near East, were using electrochemical cells for practical purposes 2,000 years before Volta, what does that mean? It means, first and most obviously, that the standard history of technology is wrong in an important respect. The invention of the battery has been credited to Alessandro Volta in 1800 because that is when the phenomenon was first formally described, systematically studied, and published in the scientific literature. But formal description and first use are not the same thing. Many technologies were used before they were theorized. It means, second, that knowledge can be lost. Not just forgotten, but completely erased from the historical record, leaving no trace except the objects themselves. If the Parthians were electroplating metals 2,000 years ago, this knowledge was not transmitted to subsequent generations. It disappeared when the civilization that possessed it disappeared. It was independently rediscovered, or rather, independently theorized, more than a millennium later. And it means, third, that we should hold our assumptions about ancient capability more lightly. The narrative of technological progress that runs from primitive tools to modern electronics is a true narrative in its general outlines, but it is not a narrative of steady, uninterrupted advance. It is a narrative of discovery and loss, of knowledge accumulated and forgotten, of civilizations that achieved things we did not know they had achieved. The Baghdad Battery, if genuine, would not be the only example of technology that was developed in the ancient world and subsequently lost. The most dramatic example is Greek fire, the incendiary weapon used by the Byzantine Empire, described by contemporary sources as a liquid fire that burned on water and could not be extinguished. The exact composition of Greek fire is unknown. It was a state secret of the Byzantine Empire, and when the empire fell, the recipe was lost. Modern chemists have proposed various reconstructions, naphtha, quicklime, various incendiary mixtures, but none has fully replicated the properties described by ancient sources. Roman concrete is another example. The concrete used in ancient Roman construction, the material that built the Pantheon, the Colosseum, the harbors of Caesarea, had properties that modern concrete does not fully replicate. It hardened under water, it strengthened over centuries rather than weakening, it incorporated volcanic ash in ways that modern builders did not understand until very recently. The specific techniques that produced Roman concrete's unique properties were lost after the fall of the empire and only partially recovered by modern material science. The Antikythera mechanism, the subject of another episode of this channel, is perhaps the closest parallel to the Baghdad Battery. A mechanical device of extraordinary complexity, far beyond what the standard history of technology would predict for its time, found without documentary context, demonstrating capabilities that were not formally rediscovered for more than a millennium. These examples establish that ancient technology was not always primitive, that knowledge was not always transmitted across civilizational disruptions, and that the objects that survive in archaeological contexts are a very small and potentially unrepresentative sample of what ancient peoples actually knew and did. The ancient world was not entirely ignorant of electrical phenomena, even if its understanding was pre-theoretical, empirical observations without the conceptual framework to explain them. Thales of Miletus, the pre-Socratic philosopher who lived in the 6th century BCE, is credited with the observation that amber rubbed with fur attracts light objects, the phenomenon of static electricity. The Greek word for amber is electron, which is the root of the modern word electricity. The observation was made, recorded, and discussed, but its underlying mechanism was not understood. Ancient Egyptian texts describe the electric catfish of the Nile in terms that suggest both familiarity with its shocking properties and practical applications, using it to treat pain, as noted. The fish was known as the father of many fishes, a name that may reflect its powerful physical presence, and its electrical properties were considered remarkable enough to record. Ancient Roman texts describe electric rays in similar terms. Scribonius Largus, a 1st-century Roman physician, recommended placing a live black torpedo fish on the head of patients with headache and on the feet of patients with gout. The therapy worked, in the sense that it did produce pain relief, through the same mechanism as modern transcutaneous electrical nerve stimulation. These references establish that the ancient world had practical experience with electrical phenomena, even without theoretical understanding. The leap from observing electrical effects in fish to constructing an artificial source of similar effects is not as large as it might initially seem. One of the most important questions the Baghdad Battery raises is whether the discovery of electrochemical electricity was made once, by Volta in 1800, with precursors in the work of Galvani and others, or whether it was made multiple times, independently, by different cultures in different periods. The history of science contains many examples of independent discovery, the same phenomenon or the same theoretical insight arrived at separately by researchers who were unaware of each other's work. Calculus was independently invented by Newton and Leibniz. Natural selection was independently proposed by Darwin and Wallace. The telephone was independently developed by Bell and Gray. These independent discoveries typically occurred among researchers who shared a common scientific culture, who were reading the same journals, thinking within the same conceptual framework, working on the same problems. The conditions for independent discovery were present. For the Baghdad Battery, the conditions for independent discovery would have been different, not researchers converging on a theoretical insight, but craftspeople converging on a practical observation. Two different metalworkers, in two different times and places, might have noticed that filling a certain container with acidic liquid and placing two different metals in it produced an effect. The practical observation does not require a theoretical framework. On this model, the Baghdad Battery represents an independent ancient discovery of an electrochemical phenomenon that was independently rediscovered in 18th century Europe. The discovery was made, used for practical purposes, and lost when the civilization that made it was disrupted and replaced. If the Baghdad Battery was a battery, the history of science needs to be revised in ways that are more than merely factual. The standard narrative of the history of science is a narrative of progress, of knowledge accumulating over time, building on what came before, advancing steadily toward our current understanding. This narrative is true in its general outlines, but it is incomplete. It does not adequately account for the losses, the knowledge that was acquired and then lost, the discoveries that were made and then unmade, the technologies that were developed and then forgotten. Ancient Alexandria had a tradition of pneumatic engineering, of devices powered by steam and air pressure, that was not preserved in the European tradition and was not redeveloped until the Industrial Revolution. Ancient China produced gunpowder, paper, movable type, and the compass centuries before Europe, without that knowledge spreading westward. The Baghdad Battery, if genuine, is part of this broader story of lost knowledge. It suggests that electrochemistry is not a discovery of the modern age but a rediscovery, that the phenomenon was observed and exploited in antiquity, forgotten. When the civilization that exploited it fell, and then independently rediscovered in a different cultural context nearly 2,000 years later. This revised narrative of science, not as steady progress but as discovery and loss and rediscovery, has implications beyond the specific case of the Baghdad Battery. It suggests that we should be more humble about the uniqueness of modern knowledge, more attentive to what might be recoverable from ancient traditions, and more aware that the disruption of civilizations has real costs for the accumulation of human knowledge. The Baghdad Battery today is housed in the Iraq Museum in Baghdad, the same museum that was looted in 2003 and has since been painstakingly rebuilt. The museum's collection is one of the most important in the world for the history of human civilization. It contains objects from Sumer, Babylon, Assyria, Parthia, and the Islamic period, a continuous record of human presence in Mesopotamia spanning 10,000 years. The Baghdad Battery is a small part of this collection, one object among thousands, and it receives relatively little attention from mainstream archaeologists compared to the more famous and better documented objects in the collection. This relative neglect is, in a sense, appropriate. The Baghdad Battery is genuinely mysterious, but it is also genuinely minor, a small clay jar of uncertain purpose, without the textual or material context that would allow definitive interpretation. It does not change what we know about Parthian civilization in any large way, because we do not know what it was. But it is also, precisely because of this mystery, a remarkable object. It sits in its museum case and refuses to be definitively explained. It functions as a battery and declines to confirm that it was ever used as one. It is 2,000 years old and still producing questions. The jar is very small. 14 centimeters tall. Reddish-brown clay. A seam of black bitumen at the top. Inside, a copper cylinder and an iron rod, waiting for 2,000 years for someone to fill them with grape juice and connect a wire. Someone made this. Someone in Parthian Mesopotamia, 2,000 years ago, sat down with a sheet of copper and a piece of iron and a lump of clay and produced, through skill and knowledge we cannot fully reconstruct, an object that works. We do not know why they made it. We do not know what they called it. We do not know if they understood that it produced electrical current, or if they experienced it as something else, a sacred vessel, a healing tool, a craft secret passed down through generations of metalworkers. We know only that they made it, that it works, and that the knowledge of what it was for, if it was for anything that can be translated into our categories, died with them. The object outlasted the civilization. The question outlasted both. In a world that is very old and very full of things we do not understand, the Baghdad Battery is a small reminder that ancient people were not simple, that knowledge is fragile, and that the past is not as thoroughly known as we sometimes pretend. The jar is small. The question is large. And it has been waiting, in its glass case in Baghdad, for someone to ask it the right way. Good night. Baghdad Battery Scriptai Hazir. Main.text Olarak Kadit, Callister.